Okay, maybe we should start again. I'm not able to play videos here because of our network. It's kind of a bummer. I'm not sure why these things are happening here. But in any case, I wanted to show you a little bit more about what Kickstarter can do. I've got this little project that I tried for a test, and you can kind of see everything but the videos, which is really too bad. If I click on it, it just says access denied, which is, you know, typical around here, I guess. Anyways, we started off with a $2,000 goal and ended up with a couple hundred backers, and now I still have 10 days to go. And I raised perhaps $6,400 in sales. And then the goal was to try and give people some kits. So I started with kits using this just parts in the board, and then I also added a thing where they could get it assembled. And then the assembly thing kind of just does this play? It's sort of funny what will play and what will not play. I don't know. If it's on Vimeo, I guess it plays, but if it's here, it will not play. So maybe that has something to do with how it's being hosted. So this is the actual board. You can see it on my turntable, and it's being viewed from all different sides. And that was fabricated on batch PCB initially. And then I went to do some demos, and I showed it on an O-scope, and then I showed its stability. This is the 3D rendering that I get from my tool, which is called Persistence of Vision, an open source tool, but it gives you sort of ray tracing, so you can kind of see what the board looks like and make sure that there's good fit for things like this pot, because this is a mezzanine bus. Boards go on top, boards go underneath, and what you want to do is make sure you have proper clearance. So you get a 3D model in there so that the boards can be stacked cleanly. If you look at, for example, the edge connector for an RJ45 jack for Ethernet, it's so tall that when the boards are pushed, they cantilever, so they tilt, and because there's not enough room. So that's typical for like Ethernet jacks. These little headers just don't give you a whole lot of room, so you want low profile everything. That's an inductor in there. So then I showed them, you know, look, here's 10, and if I can make 10, I can make hundreds, which of course I will have to do. And then if you're fabricating the boards yourself, it's much more difficult to make the argument that you can make hundreds. But if you're outsourcing the fabrication, then there's a compelling argument that all you have to do is increase the order and spend the money, and hundreds will come. So that's one of those things that kind of makes a difference. You want it to be a professionally fabricated board with the silk screen and the solder mask and the plate through holes. There are some people who say everything should be surface mount. I don't think that's correct. Look at this knob. You put your hands on this knob, you turn the knob. It needs to have mechanical security. A through hole with solder on the other side will help this knob be secure. Same thing for these jacks. People are going to stick stuff into that jack, like eighth inch connectors, and then off of those eighth inch connectors, they're going to hang eighth inch to quarter inch connectors. And then they're going to put in cables, and they're going to hook up their guitar, they're going to abuse it a little bit. You want these things to be really soldered in there. You can even see the solder buildup around the edges modeled in the 3D system, because it shows you that's the kind of thing you expect to do to make a secure mechanical connection to the board. Granted, these little resistors and maybe even this inductor and certainly the capacitors could have all been surface mount. And in fact, even this little reset button is a surface mount reset button. Comes on a tape, can be automatically placed. But it's hard to do surface mount for headers. So if you're looking at the two, I think there's 4 headers, a couple jacks, a potentiometer. Surface mount Gesundheit, that's not a good way to go. Unless you guys know more about the packaging of headers than me. And I've been trying to figure this one out. Surface mount's just not right. Last thing you need is for the copper to separate from the epoxy because somebody decided to push in a plug into your jack. That's just not good quality. And remember that the reputation of the company you're trying to build is on the line. And a reputation is not a coin, which is easily minted. So you want to try and get something out there that isn't junk, right? That's so important. Somebody suggested in the comments, why don't you just get together with a bunch of your friends and save money and have a solder party? No, I don't want a solder party. I don't want to rely on other people. If they have cold solder joints, I'm going to get returns. And some of those returns will not be from this country. There's going to be so much money spent on shipping for this. You know that if you send UPS a 4-ounce package to Armenia, it costs $85. No kidding. I just found this out from the UPS store. Now, if you want to do it with the post office, they'll take 6 weeks, but they'll charge you only $9.75. Big difference to me. I mean, you may say, oh, you're being hopelessly middle class, but look at the price of the product. It's only $29. Last thing I need is $85 in shipping. So I decided that I was getting phone calls from parents. Do you have the ability to make this for my child? Yeah, sure. What do I need? Well, you have to go out and buy an Arduino Uno. Well, I don't know how to do that. I don't want to do that. You should give me everything I need. I said, okay, we'll make a package for the kids. And so ages 10 and up, you can get it so that it has a complete package that includes the R3 Arduino, includes the stereo shield. So not everything I'm selling here is from me. Right? These are Unos made by somebody else, but I can still build a profit margin in, especially if I buy a lot of them. And this is what they're getting. They're getting a real live, quality produced system here, right? This is a proper Arduino Uno. And so at some level, I can make the compelling argument that they're getting a little extra value. Plus, it's all going in the same box, so they're saving on shipping. So why shouldn't they pay like an extra $20 to get the computer if they want it? And so then I said, what if you want 2 computers? So then the top reward has 2 Arduino Unos plus 2 assembled stereo digital signal processing shields. So as a result, you've got a $95 thing, and that doesn't include the international shipping cost, which I've only put in as $9. So I'm losing like 75 cents on shipping there, but that's okay. They raised the cost of postage in the middle of my project. It's not my fault, but these things happen. This is why you build a 40% profit margin into your product line, because you never know what the post office is going to do. You'll never know what the returns are like. And when you ask Kickstarter, how do you guys help me with returns, they say, you're on your own, buddy. So if somebody starts sending stuff back and demanding their money, you have to decide how you want to handle that. Some of those people know how to use computers. They'll like blog about you and say, oh, evil Professor Lion won't take back returns because I didn't like my thingy, or because it didn't work, or because somebody said you can surface mount an audio jack instead of do a through hole and it fell apart in my hands. So, there's these problems. And then there's a manufacturing plan and risks and challenges, and this is now required. And so now you have to describe what the problems could be. And then interesting questions come in. And, they want to know things like the specs. They want to know, why don't I clean my desk? Of course the answer to that is, hey, it is clean. You should see it now. So then, how come you're not on Facebook? What's Facebook? I joined. I have no friends. That's sad. Thanks a lot, right? How come you're not on Facebook? I don't know. Then there are these other things you put in, the stretch goals. If you meet $4,000, everybody gets the cadmium disulfide cell. So they get this is a light-dependent resistor. Somebody said, I don't have any. What do I do if I want to plug in my guitar? My guitar amp needs 1/4 inch. This is 1/8 inch. I said, you buy an adapter. You go to Radio Shack. It's $4. But then I realized they're asking me about stuff they want, So why not just give it to them? If you make your $3,500 goal, we'll throw in an extra 2 gold-plated adapters. Now, let me tell you something. When you buy 400 of these little CDS cells, they come out to be about 18 cents each. So now you're eroding your profit margin. In exchange, you're giving the backers a dividend so they can tweet about you and blog about you, and they can paint, red edit red and transform Facebook like into Facebook love, whatever that may mean. So, you get these comments, and there's a lot of stuff like this guy who says we should do it in surface mount instead of through hole, and this other guy who says the rewards are complicated, and that's because with too many rewards you have a thing called the paradox of choice. And the paradox of choice says if you have too many things to choose from, you just give up and go away and think about the purchase. So when you go to the wholesaler, what happens is, like BJ's, they give you 2 choices. You either get BJ's brand or the name brand. That's it. And that's a very successful business model. Here, you look at all of my rewards, and it's perplexing, and you actually have to read through it. So there's a paradox of choice. There's too much choice. And so that's one of the things I tried to fight. I didn't put in any reward until another reward had been used up. Once that reward was gone, I put in another reward at a slightly higher price to see if I could keep increasing the prices. Because I started with, let's say, 10 at $15. When that got used up, I said, now I'll put in another 10, let's say, at $16. When you run out of your rewards, like I did here, when it's sold out, all gone, you don't get it anymore at 15 bucks. Now you could say, but geez, how come somebody has left 1 on the table? It's because my backers weren't aware that they could save the $2, or maybe they just didn't want to bother. But this was used up, and somebody just gave up that $15 reward. They changed their mind and decided to get it assembled. Maybe. I'm not sure what they did. Maybe they decided they wanted it assembled with a computer, so they upped the reward. So, or maybe they decided they want the stereo kit. They wanted 2. So they gave up the $15 early backer reward in exchange for 2 of them, because they wanted 2. So these people, they ended up having to spend $2 more because they were a little late. And so I added that reward when this one got used up. And in fact, this was an unlimited reward at 34 backers. But then I said, you know what, I'll just limit it to 35. And we reached 35 and it was all sold out, and that's when I put in the 17. So that's kind of an interesting idea. You don't add a lot of rewards until other rewards are used up. Here's one for 25 bucks. Oh, you missed out. What are you waiting for? Why don't you buy it? If you want it, you should get it. So you missed it out. So I'll make sure the other reward is coded by a unique cost. I don't want 2 rewards having the same price, because that's how I keep track of what it is I promised people. And so if they pay $29, then I know they get a stereo kit with 2 gold audio adapters and 2 CDS cells. 2. So, yeah, it turns out that's an interesting way to go. Some people were asking for things I couldn't supply, like they wanted me to support the $50 Arduino, which includes the 800 megahertz Cortex RISC MIPS processor. Look, I'm making an 8-bit toaster controller board. I'm not making something for a supercomputer. I mean, sorry. Sometimes you have to say no to people. Someone else said, can you support the Leonardo? I said, I don't know. I don't have that. So I had to go buy one just to satisfy them. Then I sat down and we tried figuring it out. I even hired a freelancer. And between the 2 of us, that is a hard thing to do. Going from, let's say, Arduino Uno to the next generation Leonardo, that's a big deal. All the pins are different. We couldn't do it because the pins are different. We have to make a new board. Then there was another question, can you support the Duo? Totally different board layout. All the pins are incompatible. And another person said, can you support the Mega 2540? I didn't even want to try and address that problem. The Mega Arduino's got like a whole extra rail of pins on it. So a lot of people were asking for stuff I wasn't expecting. So that's kind of an interesting idea. Some people were asking for stuff that you could only have if you had extra RAM. Well, I'm not building RAM, not this shield. Maybe the next one. That's not a bad shield to have. A shield with RAM. Who doesn't want RAM for their computer? Right? A RAM shield. That's a good Arduino shield. No shortage of chips. You know how you build a shield? You find a good chip. Start with a good chip. Figure out how to use it. Build a shield around the chip. Make sure your software is right. Bang, you've got a shield. But you start with a chip. So, you know, see what's out there. Now, Microchip will make a megabit SPI interfaced RAM chip. And I just ordered 20 of them because I'm thinking, hey, this could be my next shield. And certainly it would be fun for the microcontroller class. So if you guys are interested in a fun class, take microcontrollers. Because you get to build all kinds of fun stuff. But of course, not every project is going to be built with microcontrollers. I don't know if I can play this here. Yeah, he doesn't let me play because what is wrong with our computers here? But if it's a YouTube video, will he let me play the YouTube video? That's a iffy one, huh? So I make YouTube videos, I upload it to Vimeo, I upload it to Kickstarter. That's part of the updates. With 26 updates, I may have too many updates. And then, let's see now. Oh! Yep, there it is. That's me. That's my finger. You can see, right? Can you hear it? Can you hear it okay? Yeah, you can hear that. So that's the...
On this side, we have reverb, and over here we have ring modulation.
Well, that's about all it does. Maybe that's too long. So then there's like a bunch of these. There's one in here for... he won't let me do that either? Really? I get bummed by that. You know, when my network doesn't work properly, I find it just sort of a bummer. So that's not going to work either? Really? So anyway, that's what 400 CDS cells look like. You have to buy lots of stuff when you have, you know, customers. And that'll be enough for everyone, I think. Yeah, pretty much. And I'm still surprised that you can't make that stuff work. But anyway, I had a whole bunch of examples coming in here. New sounds that no one had thought of, all in the middle of the project. So we're still doing software development, and that makes it exciting. There was one that people thought was pretty interesting, where we tried to characterize the light-dependent resistors using a logarithmic scale and then trying to linearize it by using a formula. And people said that, you know, one person said, you know, great update. This is exactly what keeps us excited. Right? So this is the sort of thing, I didn't write that, right? Somebody else wrote that. So this is the sort of thing that kind of, this guy here, he's in Italy. This guy, I don't know where he is. And it's just sort of interesting. You're getting feedback from the crowd about the stuff that they never thought of before. You know, and maybe they're getting educated by the project itself. You know, I'm an educator, so I like to explain things to people. So that all comes together in a way that, well, I don't know. You're bringing, for me, you're bringing signal processing to the masses, right? And they're interested. They're nerds like me, and they're proud of it. They're not ashamed of being nerds. So this is kind of an interesting kind of thing. So there it is, Kickstarter, such as it is. It's a great way to go to market. Now the question is, what do we do if we want to patent something in this? The answer is, well, you can maybe patent it in the United States if you do it within a year of having gone to Kickstarter. I haven't filed even a provisional. Had I done a provisional, I would have been safe not only in the United States, but also in the rest of the world. I could translate that provisional into a regular patent application for a number of different countries, as well as this one. But because I haven't even done a provisional, if there's something here I've disclosed that I want to patent, I would have to do the provisional within a year of having shown it here on Kickstarter. It's kind of a big deal, what I did. Of course, the patent people would say, you must patent everything. But, you know, patent lawyers always recommend patenting. They never describe to you the conditions, the commercial conditions for patent. That's a big deal. Let me see if I can get to Axiom Mentor so you guys can have at it. It's obvious. Who was that? Oh. Well, I mean, I got 2 uploads here from him. Both from this morning. If you zip it, it should reduce it. I zipped a 2 megabyte Word file, and it reduced its size by 90%. Yeah. So zipping is good. Let's see, zip and download selected files. Let's try this. Let's get them all at once this time. I think that's easier, right? So here's the student files. Oh, we don't know whose is whose. Shoot. Extract. Let's extract it to the ECE 420 homework file. Oh, look, they do have names. So now if I go to ECE 420, how about that? There are names. Raoul, would you like to go first this time? I'll let you go.
Good afternoon to one and all. So my concept is Vitricity. So basically my idea was inspired from other applications where they use the Vitricity concept to power up the refrigerator, LEDs, laptops, cell phones and all those things. So they were the actual device which they powered up, but not the microcontrollers or any embedded family devices that they did. So my idea was especially to power up the Arduino family microcontroller devices, especially for the low power ones, so that there is we can transmit the power in a very low frequency range, and it will be in a more efficient way. So my application especially deals with this Atmel Mega microcontroller family, it's not just for one microcontroller. There are a lot, so many kind of microcontrollers in this Arduino family, so we can power up any of the microcontrollers. So it all depends on the range of the power which the microcontroller takes. We can set the I mean, we can have a bandwidth of the frequency with which we can power up the microcontrollers, and so we can um, power up any low power microcontroller devices, especially of the Arduino family. And so, as I said, it's especially designed for the low power Arduino microcontrollers. Why? The reason why I chose the low power Arduino microcontrollers is like there are so many so many ways we can use this Arduino microcontrollers, especially the low power ones are also used in many different kind of ways in the market. It's a well established product, so I thought of powering up the Arduino microcontrollers, especially of the low power ones, with using the Vitricity concept, and publish it in the market. And the design particularly mentions about the power source integrated into the device, so that there is a copper coil which runs underneath the microcontroller, which takes the power from the um, external copper coil using the Vitricity concept and the induction coupling principle. That's it.
So, um, the goal of this project was to, this assignment, was to counter a assertion by the patent office, which we call an office action. And you are going to explain why your idea is not obvious.
I mean, like,
So what I
we
did was I postulated this idea that what you just sold us here is not patentable because it's obvious. How do you defend what you just told us against someone who says it's obvious?
I mean, there are applications like for some particular devices like refrigerator and LEDs, but for the microcontroller devices, there isn't um, any project on microcontrollers.
So you're saying it's not obvious because it hasn't been done before?
Um, Not exactly, but using the Vitricity concept is obvious, but using the Vitricity concept for powering up a microcontroller isn't obvious. So that's
So are you claiming any use of the electricity concept for powering a microcontroller?
especially for the Arduino family
So you're not
in
just
particular.
claiming any microcontroller, you're only claiming
For the
Arduino.
Arduino,
So if I change from Arduino to PIC, then I'm not infringing on your patent?
not completely. I mean,
I either am or I'm not. What are you claiming? What does your patent claim? Are you claiming any use of electricity with any computer? Or are you claiming use of electricity with only Arduino?
with only Arduino actually.
So
That's
if I
what I
change from
thought.
Arduino to PIC, then I'm not infringing on your patent.
Yes.
So you have a very narrow claim. And why is your claim restricted only to Arduino?
I mean, there are. It's a very useful product. So many so many devices. This product is used. So I was concentrating more on the Arduino microcontrollers.
So your claim is that it only works for the Arduino because it's useful for the Arduino, but it's not useful for PIC?
Maybe I'll just maybe maybe I'll just change this to microcontrollers especially, not
Well,
for
you could
the.
say that your preferred embodiment is Arduino, but why wouldn't you have a claim that lets you use any wireless electricity for any microcontroller?
Yes, that would be great.
Wouldn't that be a more
Yes,
compelling
yes.
claim?
You in a broader
Is it a
view.
defendable claim?
Yes, yes.
It is? Okay, why isn't it this case that an RFID chip has a microcontroller in it? Doesn't the RFID chip have some
Yes, it does.
It does. So isn't that powered by electricity?
Yes.
So it already exists. So if it already exists, then what if you invent it? I'm not trying to be difficult. I'm playing the role of the patent examiner. So the patent examiner says, oh look, I see RFID tags. They have computers in them. They're powered by wireless electricity. You're making a claim that anyone who uses wireless electricity to power a computer is infringing on your patent, but you're talking about technology that already exists. So if the technology and the invention already exists, then we cannot award you the patent because there exists prior art. So you can't claim that which already exists.
Well, I
You must
can
only claim that which does not exist.
well, I can claim like having a particular power. I mean, any power specification for the microcontroller. I can claim for those microcontrollers which
How about
work.
this? How about if your design for the electricity antenna was unique?
The way
Suppose
the
you
power
had a different
transmits.
way of designing the antenna. Suppose you said you used, I make this up, a fractal antenna. And in the fractal antenna you have, I don't know, a Sierpinski carpet, which fills the inductor with interesting designs for the traces that allow for unique maximum power transfer. So now that sounds like a design that you could patent. Anyone who does anything with fractal power antenna transmission could infringe on that patent.
Yes.
Especially if you can show that that's a more efficient way to move power from one place to another. Then you can patent the whole thing. But I become a co-inventor because I gave you the idea. Right?
Yes. Yes.
So, but that doesn't mean you have to assign any of the patent to me, but you still have to name me because it must be actual inventors.
So we are talking about the way the power is getting transferred.
Yeah, if you have a
So,
design for a new power transfer antenna, that's a great idea.
yes.
Now it turns out Eagle has a language which lets you script how inductors will look, so that you can programmatically design the inductors with the photomask down to 8 mils. And then you can have it fabricated with batch PCB. So you can make excellent looking shields, fine looking designs for doing the power transfer. So you build your own antennas with fractals.
Yes.
So your fractal power transfer antenna system will be presumably quite unique. That you could patent. That you could patent. So the electricity
Using
is
fractal
just like
antenna.
what has existed in the past with a difference, and the difference is we're using fractal antennas.
Yes.
Now you don't even have to care that it's working with Arduino, except that that might be your preferred embodiment.
Yes.
That could even be a way in which you bring your technology to market. But now you have a framework technology. Because now you can use it not just for Arduino, you can come out for PIC, you
For
can come
anything.
out for LEDs, you can come out for anything.
Yes.
Now you've got, now you don't just have a product, you have a business. And that could be big. Because electricity could be big.
Yes.
How's that?
Sounds good.
Better, right?
Yeah.
Who's up next? Well, let's see who's what do we got?
My brother said he put a message saying that one said inventor is the wrong one and one said your email is the right one.
Well, have him upload it again to whatever. George, you're up.
I'm up? Okay.
It's obvious.
Alright.
I like this idea of downloading all the files at once. It's much nicer. It's all in order.
Okay, well, good
I'm
afternoon.
still learning Mentos.
Yeah. Well, good afternoon. Today I will be defending my invention, and I will show why it's not obvious. Okay. Alright, so this is my original claim, and we're going to say that the office received an office action, and I had to rewrite it. So I claim that a system of powerful magnets will use the principles of magnetism and magnetic levitation to repel ferromagnetic containing bodies like asteroids and meteorites so as to avoid collision with the spacecraft. Well, now that's a mouthful. So my revised claim, I changed it. If you notice, I changed it into two separate ones. So the first one, it says a magnetic levitation system to detect and repel large ferromagnetic bodies like asteroids and meteorites in outer space. And part two, the said system is to be installed on the exterior of a spacecraft. Okay, well, this is my prior art.
You should go back to that.
Yes.
If you're dependent claim number 2.
Right.
You should mention not the said system, but the system as described in claim number 1.
Okay.
That's proper. And if you look at how claims are written in
Right.
patent literature,
Right.
they don't actually just say the said system.
Although I thought that said is you can use that, right?
In
Or
a patent, in a claim?
or I guess you can.
Yeah, not in claim.
Not in claim. Okay.
We want claim number 1.
All right.
The system described as described in claim number 1, installed on the exterior of a spacecraft.
Right.
And then you can have claim number 3, the system installed on the exterior of a spacecraft where said spacecraft goes faster than the speed of light.
Right. So it's
You could have the Warp 9 spacecraft.
right. So it's as described in claim whatever the previous one, right?
Maybe like the patent sort of warp system.
Okay. Anyway, so this is the prior art. It's the patent is the name of the patent EP 0520782B1 is a composite superconductor body and magnetic levitation system. It's basically a I use that this is the basis for the magnetic system magnetic levitation system for my that I use for my invention, and that's the source of it. All right. So why is my idea not obvious? In last class, I believe the Graham factors, Graham versus John Deere, was mentioned, and this is when you go to court to prove your invention is obvious or not obvious. This is the criteria for that, and they are the following: the scope and content of the prior art, the level of ordinary skill in the art, the differences between the claimed invention and the prior art, and number 4, objective evidence of non-obvious. And this comes from I wanted to when I looked at the class notes, I wanted to find out more about the Graham factors, so I looked it up online. Okay, so the first, number 1, the scope and content of the prior art. What does that mean? Well, the prior art is composite superconductor body and magnetic levitation system. In the description of the patent, it says invention may be applied, for example, to a carrier system for articles. In addition, a magnetic repulsion type magnetic levitation train. In my invention, however, is a new application of this composite superconductor body. It's not the same applications that are mentioned above, and so that's why. And this would be this criteria, the scope and content of the prior art is. So this is not obvious, and that's what I'm trying to prove with each of these. And for the next one, the level of skill and level of ordinary skill in the art. Solving the issue of preventing collision with bodies like asteroids and meteorites is not very obvious. In fact, it's very complex, and the thought to use maglev technology is not obvious even to experts in the field. For example, even NASA is still coming up with a way to defend Earth from asteroids and meteorites. This has been going on for several years now, and this proves that even it's a very difficult and it's not very obvious, and that's another reason why another example of non-obviousness for my invention. Differences between the invention and the prior art. Well, the invention and the prior art are very different. The prior art describes magnetic levitation technology, how it is implemented, and its applications. Once again, a carrier system for articles, example, the magnetic levitation train. My invention uses the described system in a totally new manner for a new application, not as a carrier system for articles or a maglev train. This is once again, these differences prove that the idea is not exactly obvious. Alright, so finally, the last one, objective evidence of non-obviousness. So these are more court factors that are used to prove that idea is non-obvious. One is commercial success, long felt but unsolved needs, and the failure of others. So for commercial success, although the invention has not yet been created, it has the potential to generate a large gross or profit, resulting in commercial success. So I can't exactly, I haven't made made it yet, and it's most likely a hypothetical based on large scale and funds that will be needed to build this system. So that's the hope is to generate that this will be successful. It will be needed. Part B. There will be a need to avoid collision with asteroids and meteorites. This is a needed product in order to, if mankind wants to further explore space. Something like this will be like, for example, to go to Mars, or asteroid belt is in between. So this product will be needed and to further explore outer space. And part C is a little unclear. It's not known whether the failure of others. Not many other people have attempted to find a solution to this problem. So it's relatively unknown.
That's very good. Can we go back? So it's not obvious if you can achieve commercial success.
Right, because I haven't. And well, this invention is more or less hypothetical. It's not guaranteed that this will be. Might take a long time, and I may not have. It's more hypothetical than anything else. So I'm not sure.
Let me backtrack a little bit.
Yeah.
So suppose I said Professor Lyon has a DSP shield.
Right.
And he has $6,000 in sales. That might be sufficient evidence to show commercial success.
Right.
But I also have to have, right? It's not enough to be commercially successful.
Right. Right.
Because I could be making, I don't know, some commodity.
Sure.
Right? So now I also have to have a long felt but unsolved need. So I could say, well, lots of people need to do audio. Maybe
Right.
people have tried to do audio for 100 years, since Edison and the Victrola. I don't know.
Right.
Audio seems so important. It's obvious
Right.
that it's important. So then there's this failure of others. Now comes this other thing, failure of others. How do I know how many people have failed trying to create audio shields? Well, I can go to Kickstarter and I can say, here's a bunch of failed shield projects.
Sure.
And this is obvious. Others are failing. So they didn't get funded. It's a failure. And so now I can claim, look, I not only have failure, but I have documented failure. So I can't argue about prior art, but I can make a compelling argument that it's not obvious.
Right. Yeah.
Huh. That's very...
Any questions? Well.
Bobby.
So I'm back with my old idea, finding maximum power point tracking for the Wien power system. So let me recollect my abstract and my claims. The usual power point tracking for wind systems is calculated using this TSR method. but it's not it don't show its efficiency with the power variation in the uh, power coefficient. To improve this, I have an idea, and I propose some of my claims. This is a rough draft. It's not the exact draft that goes for the patent application. Uh, I propose three modes of working turbines. Um, if the wind variation and speed of the blades are optimal, I'll go with the TSR mode. It's just like the previous right now how turbines or windmills are going now.
Tell us again, what does TSR stand
A tip speed ratio.
for?
Um,
What does that mean?
it's a coefficient of power coefficient. It's like with the tip speed ratio, the power coefficient is varied. It's like directly proportional. The power coefficient is varied with the tip speed ratio. So the other mode is like hysteresis mode. About this, with the using the concept of hysteresis, it's like getting the prior data and processing it for the future. Um, and the third thing is that if the power coefficient values are very high, the control unit just turns to the steady mode operation. These are the claims that I want to propose, and it's not obvious because the wind systems right now they are running with TSR control methods, and the method I am proposing is completely different, which can bring efficiency to the current windmill systems. And this is a patent which is close to my idea actually, but it's totally different. It just explains the basic TSR control method, how it works and how it switches between TSR mode and disabling TSR method. And this is the second one. This is the other method uh, which explains the dynamic switching between the modes. Um, so at last I can say that, so when these two patents have been patentable, and my idea is totally different, and which is an completely a future solution for the efficiency of calculating maximum power point tracking. So I won't say it's an obvious thing.
So let me understand your idea. You're going to select for a range of powers, and,
Yeah.
and then that range is going to be when you start to kick in the buck boost converter, and then you have another range of powers where you don't use a buck boost converter. Is that right?
No, not that. I mean, actually, when there is a lot of wind variations, that's the reason we use this maximum power point tracking. Uh, things that when I calculate the different modes using the power coefficient. If the power coefficient variation is very high, which is like I'm not using the turbines efficiently, I'll switch that to a steady state mode. I'll use a controller unit which switches between these three units. The steady state mode is something like using an braking system or changing the direction of blade so that the uh, wind speed is maintained. That's a steady mode, and the other mode, hysteresis mode, is something like I'll collect the previous data like voltage or current or TSR things, and I'll process it. And this is the mode where most of the power coefficient is maintained. And the next mode is normal TSR mode. I'll put a control unit which will be switching between these three modes to get efficiency of the wind system.
Are there any questions about this? You must admit I don't understand this
Yeah, I mean,
Is your invention instead just something mechanical? Is that it?
it's not mechanical.
So what are you adjusting?
I'm finding a control unit which is switching a mode of operations.
So you're adjusting the mode of operation.
Yeah.
But the
These
switch mode power supply is not
Yeah, I mean, these
adjusting
are my
the mode
prior
of
work.
operation, it's just adjusting energy.
These two patents are my prior work. Like, these are the ideas that made me to get my
Okay.
Right, it's based on how much when there's failures coming in, when the most variable, so that's okay. There's like basically depending on how much wind there is, like it adjusts.
Yeah, so
Yeah.
if there's low wind, what does it do?
It just operates normally, like TSR mode. Like TSR mode is where you'll have it operates in normal way, normal how right now normal turbines are running in low
So
winds.
then when there's high wind, what does it do?
It's just the high winds. The main problem is that we'll shut down it, or we use mostly a braking system to run that optimally. I propose,
So high wind it changes to a braking mode.
yeah,
And that they don't do that now?
they're doing that. I mean,
Oh, they do it. So what's your invention?
I'm introducing an hysteresis mode.
So your invention is hysteresis.
No, hysteresis, not hysteresis. It's like I'm including a mode, and with the control unit that switches between this hysteresis mode and this steady state mode and TSR mode.
So it's a controller.
It's control.
It's a control law.
Yeah, control
So
unit.
you're patenting a control law.
Yeah.
Okay. Thank you.
Thank you.
I'll be right back, guys. Is it getting any cooler in here? No. We're engineers. We should be able to figure out how to sabotage the heat. I don't think I've done. They've nailed it shut or something.
You want me to start? My project is about smart grid for domestic use with power outlet power sensing, and today I'm going to tell you why my idea is not obvious. My idea is depending on 3 patents, and this is the first one. The first one is energy consumption and determine. The first one is the first one. First point there.
The first one is the first one.
I just don't want to read the whole thing there. That's why I'll just explain it. In that one, it tells us individual device, but it will note down all the power of the individual devices, and it will count all of them, and it will aggregate the whole thing, and then it will give us the exact amount of power used by that device. And what I am doing is I'm doing it for an outlet, so that whichever device is connected, we can find a power for that outlet. Instead of a device which has to be connected, I'm connecting an outlet which is calculator.
So it's obvious.
No, it is not, because I'm doing it for an outlet instead of a device. Instead of doing it for each and every device, I'm doing it just for an outlet, so that they can connect any device for it and they can calculate the amount of power.
But don't they already have devices that compute the power for an outlet?
No, they just we have to connect it to them. They just have one outlet like wattmeter and everything. We just
Yeah.
have to connect it to an outlet, and then this one, it reads all the power usage, and then it will send to a central unit in the house, where each and every device usage of power is noted down
So how does it communicate to the
through the
outlet?
sensors, Zigbee. I'll just explain.
XP or Zigbee?
Zigbee.
Zigbee.
Yeah.
Why not? Why doesn't it use X10?
I didn't. I have no idea. I just
Well,
read
if
it in.
it's plugged into the wall.
Okay.
Presumably it has access to house wiring.
Mhm.
The house wiring is capable of carrying carrier current transmissions. So if you use the house wiring to transmit, you can go at power unlicensed and go back to a central hub. So X10
Okay.
is an established technology. It's been around since the 70s.
I'll
And
just read about it.
yeah, it has it's used for control of power systems.
Mhm.
Usually has 256 different addresses. So you use a major address like A for a specific room, and then you can have up to 16 sub-devices in that room. And you can control all the devices remotely through the carrier current transmission.
Mhm.
So X10, if you know it's going to plug into the wall, is an obvious better way to go, because you don't have to worry about distances. It'll be a whole house system.
Whole house system, yeah.
Yeah. House automation is very common for people who are interested in stuff like Arduinos. In fact, there are many books on Arduino automation that try to address the issue of doing control over the house wiring. And when you do control and digital communications over the house wiring, people use for low data rates, carrier current.
And this is the next patent. In this one, they're connecting a bus bar which is used in the data centers for a main server, so that the data will be used effectively, and then even the power, even they can find out how much power is the whole data center is using. But now what I'm trying to do is I'm trying to find out the individual usage of device. So I'm just using a bus bar which is not more than 4, like it will have 4 plugs in it, and then whenever we connect a device into it, it will note down the power, and then it will send it. This is the second one.
So now you've got the power strip, and it has to communicate all of the elements plugged into it individually. It's not aggregated.
Yeah, that is already in use. They are using it in data centers right now.
Why does it have to be not more than 4?
No, what? Because house, I don't think you'll have a outlet which has more than 4.
I think I have more than 4 right
This
in
is
front of
not
me.
a house.
I have outlets all over my house, power strips.
Maybe, I have no idea. So for a
I
device,
think the idea in the claim that you should limit it to 4 makes no sense to me, because all I have to do to get around your patent is to put in 5.
okay, I'll just
You
remove it.
You might say that in the narrative you have a preferred embodiment of 4 because this is how you constructed it. But when you go to make your claim, I think a bus bar should be able to accommodate many outlets.
Yeah,
I think so.
I'll remove it.
Not in the claim.
Yeah, this is not a claim.
Yeah.
This I'm just explaining it. And this one, the first one, this is the third patent. The smart grid and method for operating a smart grid. There they're using smart meters to transfer all the amount of power usage from home to a central power unit. Here what I'm trying to do is I'm trying to use these signals in the form of Zigbee to transfer data from inside the home, and then from the home to central hub, power central hub.
What is the range of Zigbee? Can you reach the whole house with Zigbee?
I think, yeah.
Yes? And can you
I think using a Wi-Fi and
is Zigbee better than XBee?
I don't know about XV.
Oh. Well, I mean, you made Zigbee sort of the centerpiece of this patent. It seems to me like I should be able to get around the Zigbee patent if I just change to XBee.
I think we can use Zigbee or Bluetooth or Wi-Fi for all these.
Well, I mean, you say Bluetooth, but Bluetooth is only good for 10 meters. 10 meters is the distance between you and the back of this room. It's
Okay.
not going to be the whole house.
So
Don't use Bluetooth.
okay, no Bluetooth.
If you're using Zigbee, you're obviously running at a power level which hopefully is unlicensed. Otherwise, every user will need a license. So there's going to be limited range.
Okay.
It won't necessarily go through cement walls. And maybe you have problems with rebar. So I'm thinking you're better off with a whole house data transmission system that runs at low data rate.
Okay.
I don't know the range on Zigbee. You should know it. If
Yeah.
you don't know your numbers,
Yeah,
you'll not
yeah,
get
yeah.
funding through your venture capital.
And yeah.
They'll be harder on you than me.
Yep.
What else?
That's right.
That's it?
These are the main three patents which my idea is related to them. So
Well, you better know about X10.
X10,
Everyone
yeah.
will ask you about X10.
Next week.
Hi, good afternoon. Dry ice superconducting motor. I explained last week about claims that, like, all the claims that I mentioned.
If you hit F5, it'll go full screen.
Okay. Thank you.
Well, if you're ever presenting to others, you'll, not just us, but professionally, you want to be sure you're full screen.
Okay. So, like, under 35 USC and 102, they mention like it's obvious kind of thing, like they mention like that official action. We can say it's not obvious by these two kinds. Prior art, based on prior art that is available, and the one who is skilled person is not think it's obvious. So I'm going to explain why my idea is not obvious. Prior work only have permanent magnetic motors till now that we are using in motors, but superconducting motors are not available right now in market. And they recently, some Cambridge University guys, they invented superconducting motor which is high temperature, not dry ice temperature. So there's no prior work related to dry ice superconducting motor at like temperatures that is at 195 K. So I think
I don't think you mean high temperature, I think you mean low temperature. Right?
No.
They're running at liquid nitrogen, and you're running it at CO2. So you have the high temperature.
Yeah, but they when they mentioned it's high temperature superconducting motor, but our dry ice superconducting motor is high temperature than they built.
Yeah, right. You're 100 degrees warmer.
Yeah. So they didn't. No one worked related to dry ice superconducting motor. I searched so many sites, like, but I didn't find any dry ice superconducting motors related to dry ice temperatures.
So you have a compelling argument here. You feel that you have a high temperature superconducting motor that's sellable. There's commercial aspirations. And then there are these aspects of no prior work. And what was the other criterion for obvious?
Cost and efficiency. commercial success.
Failure of others. Can you cite others who haven't been able to get this to work? Anyone ever tried this before?
I have searched so many things, but no one did work related to dry ice motors, dry ice superconducting motors.
Okay. I'm sold. I want one. How much is it?
I'll write my.
Can I buy it now? I think it should be on Kickstarter. You should have the dry ice motor, and it should go into a model airplane. But the trouble is the dry ice is too heavy. Although it is only gas. Still. I have seen dry ice motors, but they're not superconducting motors. They just use the pressure.
If we use superconducting magnets in motors, we can decrease the size of the motor.
Well, they have superconducting magnets that work with dry ice.
Yeah, they invented that superconducting magnet.
So why can't we have a superconducting magnet that works with dry ice with a superconducting motor?
Gee, that's what my idea is.
Oh, that's maglev. So maglev uses dry ice superconductors?
So when I mentioned claims in last week, I explained in claim 2 that that is used superconducting magnets that is used to get superconductivity at dry ice temperature. Because of using superconducting magnets in motors, we can decrease the size of the motor. So that's the basic importance in motors, right? If we decrease the size of the motor, we can achieve good like compared to other things, other permanent magnet motors. So like if we are using superconducting magnets in motors, we can increase the efficiency of the motor. That's why I think this is not the obvious idea like to be patented.
Thursday, the one piece of information that was included in the limit, you can't upload it to Inventor because it's working right now.
Does it work?
It's gonna work, and he can't do it.
He can't do it because it doesn't work. But he has something on Mentor. I mean, we just see something, right?
He has something.
So let's see which one is later. Actually, they're both about the same time, aren't they? But this one is bigger. Security. Alfredo, what are you doing to us? Update links. Cancel. Or update links. If you update links, cancel. Okay. Oh. Alfredo, can you save this to a different format next time? Play the content. Try the player to play the content. Yes. Yes. Well, Alfredo, something is wrong here. No. Yes. I really don't know what to do. So I'm going to narrate. So it looks like Alfredo's got this thing here, which has got this microphone, and I dare say there's some kind of high pressure level going in and a low pressure level coming out. And somehow there's an audio system which creates destructive interference. Don't ask me again. So let's see, we've got active noise cancellation within Engine Technologies, combined with the use of an algorithm that uses FFTs that creates a power spectral density in real time. Audio system speaker consists of 6 speakers. Each speaker has an inclination of 5 degrees and distributed uniformly inside the muffler. I wonder how he knows it's going to be 5 degrees. 6 speakers times 5 degrees is only 30 degrees, right? So here's the letter to show that this is not obvious. This design implements the cancellation of high energy harmonics. And this is why it's not obvious. Okay, the description of the design is not a defense. Right? The defense legally has to include things like there's no prior art, or there's commercial application, or others have tried this before and failed. But the fact that it uses an FFT is not sufficient. I think what we'll do is we'll get out of this because it's not working, unless this can work. Cannot play the file. So something is going on. It's a technical problem. Apparently we cannot play the audio portion of the PowerPoint. I imagine this has something to do with versions. The algorithm controls the waveform that is sent to the audio system speaker. Each speaker's inclination of 5 degrees facing the center of the muffler in order to get a uniform signal. Speakers will be distributed uniformly. But why isn't this obvious? 4 microphones will be used. Is that what the part about what's obvious? I mean, suppose I use 5 microphones. Is that better? What are we patenting here? 4 microphones? What's the patent? Is it 4 versus 5? If I use 5, am I not in violation of the patent? I don't know. Signal processor, let's see. Quiet fan. Okay, so here's a patent. Freedom and Rubin. Quiet fan incorporating active noise control. Quiet fan using active noise cancellation. Let's make it a little bigger so we can see it. The difference between my design is that my algorithm focuses on high energy harmonics, and the microphones and the audio system are completely different. The time and calculations that I spend on this idea are not easy to achieve, and this is another reason why my idea is not obvious. Okay, so the part that's not obvious here is that there's something about this algorithm that's complicated. Is that a defense against obviousness? I'm not sure. Yeah, if I wanted to tell you that this was commercially viable, I could make a compelling argument for it. If I wanted to tell you that no one has ever done it before, that might be good. No prior art. What else do I need for commercial? Obviousness. Not obvious. George, what was one of your criterion? I got the prior art, I got the commercial. Failure of others. Has anybody ever done this before? It doesn't seem like the active noise cancellation fan is something that you should be able to buy. Let's see. Suppose I went to Google, and then I wanted to go into Google and buy active noise cancellation fan. Does anybody sell that? Looks like there's something here. Noctua. Silentium. Silence in a chip. So let's see, we've got a microphone, an S-Cube, and a speaker. Silentium, the winning solution. 90% noise reduction in your product. This looks like something I can buy. Silence in a chip. Silentium. Geez, I could do this with my Arduino shield. Buy now. Silence in an Arduino. It doesn't look like they're gonna, oh, the Acoustarack. They've got the silencer fan, silencer docking station. Looks like there's a bunch of stuff here. Silentium. Oh, you can even buy the, you can buy a kit. The S-Cube development kit. This looks like something I can buy, right? That looks very product-y. Very, very product-like. Doesn't this look like something you could buy? I could sell this on Kickstarter, right? Oh wait, it's not mine. I don't want to sell theirs. I could sell my art. What if I have a good idea. What if I take FFTs and put it into my Arduino, and then I use that to generate the sound coming out of the speaker. So now I have microphone in, and then I have sound out, and it does active noise cancellation. I could use a giant guitar amp to make enough noise to cancel. Doesn't that sound like a good idea? And if I file first, then I win, because we're going to be a first to file country, right? So I have this idea that maybe what is happening here is we've come back now to the invention part of your patent. And at this point now, we need to nail down some aspect of the design that makes it look non-obvious. So I think it's time for a little narrative. Let's see. Axiom. Mentor. Independent study. We'll make an assignment. Create new assignment. Why is no assignments found? This is the wrong course. This is not my beautiful course. Here, change the course. Assignments. Okay, so let's create our new assignment, and it's a homework. And parent, yes. I'm going to change this now because I find it very tedious. So what I want here is create a societal, let's see, we'll call it societal impact. Weight is 1. Save and edit. Do. Here it is. Homework. Display on. Submit electronically. On. Okay. Create a PowerPoint presentation that describes the societal impact of your invention. Now, to try and sort of see what others have done, what you might like to do is go to docjava.com. Hopefully that'll work. And then look at some of the prior work in the field. So, for example, is there a thesis work stuff in here? Every one of my proposals in here talks a little bit about societal impact. And so societal impact is a part of a thesis requirement. So, like, for example, Francisco and Pavel both worked on a way in which to do network of workstation volunteer computing based on screensavers. So, you know, computers are always depreciating, they're always throwing off heat, they're always sucking down power. Why not use them when they're idle? Most of the computers in this room remain idle all day long. If they're asleep, they should have a screensaver that comes up that allows them to volunteer their CPU into some sort of pool, which can give them jobs to do. So in a sense, that impacts society in a positive way, right? That's kind of like green computing. It's using the unused CPU cycles. So you know, the other one, Nishant and Ian, they were doing portable face recognition for the identification of terrorists. So this is an idea that might keep people safe. You have a little PDA, you take a picture, and all of a sudden it tells you, oh, this is a most wanted person. You know, this is very important. Gino, he had one that was doing 3D range finding, which might have applications for biomedical devices for doing diagnostic work. So that could help society. Bob Distinti, he was doing one with inductors so that people could communicate better using cell phones. And if you had Y-tricity and you had this inductor technology, maybe there are all kinds of interesting ways in which society can be benefited. I can't even think of the ways that you'll think of by next week. So every one of you has an invention. You should all be considering how it serves society. If you think it's a commercial product, then perhaps people will want it, therefore it must serve some useful function. So let's think about the ways in which society is served. So you can do service by virtue of making life better for people in some way. Right? So for example, you could say, oh, I'm inventing clothing. It will keep people warm. Right? I mean, stuff like that. A superconducting motor, maybe it benefits people because it saves energy. Or maybe it goes faster. Or maybe it goes... why would anybody want a superconducting motor? Does it go faster? Oh, okay. So it may be more efficient. Saves energy. That's very good. So all sorts of ways in which you can describe this. Your presentation doesn't have to be long, but you need to think about these things. It will become a part of your thesis proposal. So thesis proposals always talk about societal impact. And you'll look at prior proposals from well, maybe I can give you the full URL. There. And in fact, if you're really clever about it, you probably take the whole thing and put it in as a link. There you go. There, now you can click on it. And that should take you straight into the DocJava web page that shows you the prior thesis work. That also includes PowerPoints. But yours will be yours. But you might like to look at the others for inspiration. And this is due next week. And I've gone over the allotted time because it's already 2:33. So thank you very much. And enjoy the rest of the week.